Okay, today we're going to find a way to express a sign in a different format. To do that, let's recall some component from pure math 1 here. So if I ask you to solve this question here, 5 sin x equal to 3 cos x, then you will know that you can't progress with this simply because you have two trigo here. One is sine and the other one is cos. So your instinct will tell, okay, let me divide both sides by uh, cos x. So we're going to take this and divide by cos x, and we're going to take this side and divide by cos x. Why are we doing this? Because we want to get the tangent x. It's only one trigonometric function, which will make the solution easier for us. Then what you will do, as usual, you will go and find the answer in the first quadrant. Like, what is shift tangent 3/5? You're going to get 30.96, and then you know tangent is positive in third quadrant. So what you will do, you will do 180 plus 30.960. So you get two answers, you will be happy. Now let's look at the extension in A2 level here. So your question here, it's going to look more or less the same. Let's find the difference here. Do I have 5 sin x? Yes, I do. Do I have 3 cos x? Yes, I do. But now I have an extra fitting here, which is plus 2. So can I simply go and divide by cos x like what I did in AS level? By doing this, yes, I know that I am creating a constant value here 3. I know I am creating a tangent x here, but I am creating secant x now. 1 over cos x is becoming secant x. So what is the problem at this level? My aim is to reduce two trigo function into one. See, when we did it here, we only got one trigo function and the solution becomes easy. But you can't do the same thing here. So how do we handle this problem? That is the lesson today. So in order to do this, I am going to introduce some concepts. What is that concept? If you look at your key point 3.5, they are telling if you have something written in this manner, like a sin x, a sin x, b cos x. I mean, I think I'm not good in this, but try and follow. A sin x, yeah, b cos x, it's equal to r sin theta plus alpha. So they are giving you two formats like this. They are telling that if something is written in this manner, then it is going to be definitely r sin theta plus alpha. If it is written as a cos theta plus minus b sin theta, then it is going to be r cos theta plus alpha. What is this? It looks very confusing. I don't understand. And then they are telling that to find the r value here, this r value here, they have a shortcut. And then to get the alpha, they also have a shortcut. Okay, let's try to understand what is the meaning of that. So they are saying, let's say for instance, when I'm trying to solve this question, they say don't do this, but they say just bring the 5 sin x and the 3 cos x to one side. And they are asking me, hey, can you change this into another format like what I'm giving down here? So let's check the compatibility here. I have a sin theta. So in my case, my a is 5. And then I have b cos theta. And my b value here is exactly 3. Please note that they also have a negative. So in that case, they are saying, hey, you can actually write this as r sin theta minus alpha. If you have a minus here, then this part will be a minus, it seems. Do not worry, because your level, they will give you this format. If they are giving you such a question to be solved, then they will give you this format. You don't have to memorize how it works. Yeah, you get this part, yeah. So now let's move on, and I'm going to prove it to you how they actually got the r value there. Their r value here, if you see, it is square root of a squared plus b squared. Okay, let's find first what is our R value. We follow what they are doing. If I look at this, I know my A is 5 and my B is 3. So if I apply the rule, I should get 5 squared plus 3 squared. What is that? It is 25 plus 9, which is 34. Square root of 34. Okay, that is our R value. And then they say to find the alpha value, to find this alpha value here, I can just do tangent alpha is actually B over A. What is my B value? It is 3. And then what is my A value? It is 5. So by doing this, they are saying you can actually get the alpha. And what is our alpha? It is 30.96. So this is our alpha. So let's go back to where we started. We were so confused on how to solve this question because we cannot express them in one trigo format. Trigo function to be precise. So I am using a guideline given in the textbook exactly here, and I'm trying to change this format. So when I changed it, I realized I actually managed to express it in the form of r sine theta minus alpha. So it is r sine theta minus alpha, which is equal to 2. So sert 34 sine theta minus 30.96 equals to 2. So look at the magic. What did just happen? I realized that, oh wow, I can actually express this in one trigo function now, which is only sine. I managed to demolish the cos x. It's vanished. Can you find any cos in here? You don't. It's only one sine. And the solution to get the x value becomes easy. Okay, for your information, the variable here is x here. So I should be writing here as, I should be writing this as x. This is what you are aiming for now. See, to find the x, it becomes easier now. So what you will do, 2 over 34, then you will do as usual. I think this one you already know. Then you will be able to get the x. But now we have to find out why the r is expressed in this format and why do they say tangent alpha is b over a. So let's take an example and then we study from there. Okay, let's check what it is saying. They ask us to express this in this format given. So as I told you, this format will always be given to you. It is a guided problem. Why are they even asking you to express? Because they want you to solve this problem. When you are solving this problem, you cannot be having two trigo. You cannot be having sine and then the cos. You should express it as one trig function. And where is that one trig function? It is the sine here. So as a step 1, you use your compound angle formula and expand. You have to expand the r sine theta minus alpha. So I have done that for you here. Can you see? I taken this and then I expand using my compound angle formula here. Check. Sine theta cos alpha and then cos theta sine alpha. And then I made sure that I have a minus in the middle because this is a minus. Second step, if the question says that I can take this and express in this format, it means they are actually equal. Okay, so I am introducing the equal sign here. I'm going to take all of these and then write it at the bottom and then I want to compare. Okay, let's compare. Let's see what happens when I compare. I have a sign here and then I have a sign here. I have a cos theta here and then I have a cos theta here. So this is how I am going to compare. So look at my next part, yeah. So I am taking the cos and comparing with the cos here. And then the sine with the sine. So which one can I cancel? Which one looks alike now? Oh God, I want the read. So you know that this and this looks alike. So I can cancel it. I know that the cos theta and the cos theta here looks alike. So let's see what's left now. What's left? The 2, I put it down here. This is gone, this is gone. So left with r cos alpha. The minus gone with the minus. The cos theta gone with the cos theta. So 3 is equal to r sine alpha. So almost there. I have sine and then I have cos. I'm happy because I know I can literally introduce tangent alpha. So I'm asking you to divide both the expression. This is expression number 1, expression number 2. You divide. You take the 2, you divide by the 1. So you will get r sine alpha, r cos alpha equal to 3 over 2. So in this case, the r and the r get cancelled. And this gives us the tangent alpha and we got 3 over 2. So let's check. Let's check now whether the formula is making any sense. See, I already obtained this. I want to check whether my tangent alpha is exactly b over a or not. Okay. So which one is my a and which one is my b according to the question. You take this and you refer here. Isn't your a equal to 2 and your b equal to 3? So now let's take the shortcut and check. So your tangent alpha is exactly going to be 3 over 2. See, the shortcut works. Okay. This is how we actually derive towards the shortcut. Then you can find the alpha by doing tangent inverse 3 over 2. We are left with one more. How do they express the r? How do they express the r? So what I'm going to do, I'm going to take the 2, the second expression here, and I'm going to square it. So I get 9 is equal to r squared sine squared alpha. I'm going to take the 1 and then I'm also going to square it. 4 is equal to r squared cos squared alpha. I have cos squared and I have sine squared here. And I know sine squared plus cos squared is exactly equal to 1. So let's add this expression. 9 plus 4 is 13. R squared sine squared alpha plus r squared cos squared alpha. I factorize the r squared. I'm going to get 1 based on this. And this is a 13. So my r squared is equal to 13. Therefore my r is square root of 13. So how did we get this? This 9 and 4. That is what they are saying. They are saying take the a, square it. So if I take my a and then I square, I get a 4. If I take my b and then I square, I get a 9. So that's what happening here. And then when we add, we actually getting 13. Whereby this part becoming 1. That's why they put a cert. The cert comes this side. Okay. So that's how you manipulate. You can always stick to the formula. You don't have to do the lengthy way. But you are always advised to be able to use the compound angle formula to expand the format given to you in the question. Then you can just solve them regularly. Okay, now let's try some question from the beginning. Okay, we're going to go into the shortcut and see how it works. Now the part A says express in the format. See, the form is actually given to you. So let me use the shortcut for the r. The r say take the a and you square it, take the b and then you square it. Now at this point you might be asking, Miss, which one is the a, which one is the b? I don't want to memorize any rule. So the tips is this. Just take the coefficient in front of the sine and the cos and then you just literally square them. Don't care which is your a, which is your b. Take this and square. Take this and you square. Okay, whatever you get, you write first and always leave it in the cert format. And furthermore, the question say exact value. Cert 52. See, when I'm solving this, I really didn't guess which is my A and which is my B. I'm just going random. I know that it is 4 and it is a negative 6 here. Then the second part, I know the rule says to find the alpha, I have to do something like B over A. But I don't remember, I don't recall which one is the B and which one is the A. I'm going to teach you a shortcut here. You go by this rule. If the question here is a sine, see, they ask you to express this in the form of a sine. So what you do, you go and find the coefficient of sine in the, oh god, in here. So what is the coefficient of the sine in the question? Isn't it 4? So that 4 will go down. Whatever that is similar to the format which needs to be expressed, that coefficient will go down here. And then you take the remaining one and then you put it on top. Do not put the negative because you only want the acute angle. In the first quadrant where the acute angle lies, everything is positive. So you neglect the negative and then you find the alpha value. 56.31 degree. 2 decimal place cube. Then the second part we go and solve as usual. So in order to solve this, first you express. So what is your answer? Cert 52. Cert 52 sine theta minus 56.31. See, hence. The word hence tells me that I can actually use the format up here in order to express this. God. So let's use this one is exactly equal to this, which I already wrote it here, and must be equal to 3. So solving this will leave us with what? Sine is positive, so first 2 quadrant, and all of this is worth how much? Theta minus 56.31. Let's write the answer in the quadrants first. The answer in the first quadrant is sine inverse 3 over cert 52, 24.58. So this is 24.58. In the second quadrant, it's 155.42. Therefore, your theta value, you only want answer from 0 to 180, yeah? So I can say it is going to be 24.58. You have to reject the other answer because it will exceed the limit, so don't take this. So your theta value will be 80.9 degree. Okay, see the solving part, I think you are very good. It's just that the first part. Now the third part is a little interesting. For this you have to know little bit of concept. So let's say you are doing sine theta graph and the cos theta sketching. Okay, so how does a sine x looks like? The highest value 1, lowest value -1. How does a cos x looks like? In this manner, highest value 1, lowest value is -1. And then recall a little bit of your pure math 1, sketch of sine squared and cos squared. So what is happening when a function is being squared? You know the lowest value it will take is 0. So in here it is ranging from 1 to -1. But the moment I square the function, what will be my lowest value? Don't say if I go and square 1, I'm going to get 1. If I square -1, I'm going to get 1. So my answer is from 1 to 1. 1 to 1 is not a range. 1 to 1 is just 1. So there is a middle value here. If you take the 0 and you square, you actually getting a 0. So the range of a sine, it's going to be like that. If you draw, you're going to get that. So 1 to 0. Same happens to your cos. If you sketch, it will be from 1 to 0 because there is a middle value here you are squaring. So 1 to 0. So using this concept, let's solve your part 3. They say find the biggest, greatest and the smallest value of this expression. I know that this one here is exactly this, right? But the one thing extra I have to do is squaring. I have to go and square this function. So when I go and square, what will I get? I will get 52 sine squared theta minus 56.31 minus 3. You don't forget the minus 3 at the back here. So now let's do a little bit of thinking. Okay, I know this is 52. I know this is minus 3. Okay, I understand the sign is being squared. What is this thing in the middle? This one affect your movement to the left and to the right. Okay, whether it's going to move to the left or right. It's not going to affect your movement of the graph up and down. It will never affect. This angle here, the adjustment is on the x-axis. So it's moving to left and right. So what you do, you just ignore the angle. Whenever you see sine squared, you know a sine squared is from 1 to 0. Isn't that what you did here? It's just 1 to 0. So multiply 52 times by 1, it's 52. 52 times by 0 is 0. Then you have minus 3 and minus 3. You just add the minus 3 here because this part is multiplication. This is a minus. So what will I get? 49 and minus 3. So the greatest value here is 49 and the smallest value here is negative 3. Okay, you digest the information. Let's try another one using the shortcut I taught you. Number 8. Now express, they have given you the format. Just take the format and do it. How do I do the R? I told you, don't think about the A and B. What is the coefficient in front of the cos? It's 1. Take that and square. What is the coefficient in front of the sine? It is negative 2. Take that and square root. You're going to get 1 plus by 2. So it is 3. Exact value. So I leave it in exact value. Now I have to go and find the alpha value. Okay, let's check the shortcut I taught you. It's always tangent inverse. But now you need to put here the coefficient of the similar trig function. Question give me cos. So I look for the coefficient of the cos now. What is the coefficient of the cos? Coefficient of the cos is 1. So that 1 will go down. Then the remaining you just put it on top. This is a shortcut that I created looking at the patterns. It's similar. Okay. No much thinking. It just always works. So shift tangent 2. What are you getting? 54.74 degree. Simple. I got the R value and then I got my alpha value. Now let's go and solve part B. Hence, the moment I see the word hence, I know there is a connection between the upper part and the lower part. So what is the connection? This, what do we? This one here. I think you already saw the connection. This is exactly same like this. So just write it. 3 cos theta plus 54.74 degree is equal to negative 1. So cos all of this is negative 1 over 3. So which quadrant now? Where is cos negative? Cos is negative in the tangent and the sine. Second quadrant and third quadrant. And I know all of this is equal to theta plus 54.74. Let's find the answer. Let's find the answer in the ticked portion. If I want to find that, I need to find the answer in the first quadrant. So cos inverse 1 over 3. Do ignore the negative here, yeah, if you want to find the answer in the first quadrant. It is 54.74. Oh, looks like they are the same. 54.74. So 180 minus the answer. Here you get 125, 26. And then here you're going to get 234.74. So now let's solve. So how do we solve? I'm going to take all of this and equate to this one. So theta plus 54.74, it's 125, 3 degree, 234.74 theta. I know if I bring this here, I will definitely get 180 because they are the same. And then this one will leave me with 70.5 degree. So that's how you get the theta. I think you don't have to go more rotation. It is all within the 360. Now let's check on part C. I think part B is simple if you already got the part A. And of course part C is thinking. Question wants you to find the least value. What is least? Least means smallest value. Smallest value of this expression as theta varies. Now how do we do this? Of course I want to look for some connection. I look at this and then I look at this. Do they look the same? No, my cos theta here has a cert 2 in front. And then my sin theta has a 2. So it means I have to try to make the coefficient of the cos theta as only 1 so that I can use the comparison. So let's do some adjustment. This is what the question says. Okay, this one needs some adjustment like that, and then they have a square. So I know that I don't want the cert 2. So of course I am adamant I will go and divide by cert 2 here, and then I check. So this will give me cos theta, and then I use calculator to check what is 2 divided by cert 2. It is cert 2. See, now I'm getting the format. I'm happy. But I have to balance everything now. I have to balance the entire expression. I cannot simply bring in 1 over cert 2 because there is a square here. So what am I literally doing? I'm actually multiplying the upper part and the bottom part by half. Okay, how do I know this? Because the inner part is 1 over cert 2, right? You just go and square it. You will get 1 over 2. So this tells me that, oh, you have to take the upper part times by half, take the down part and times by half. So what's left now? It's 1 over 2 from the upper part here. You multiply, and you already used the half here to multiply inside here. So this whole expression becomes half over, what is our R value? Cert 3 cos theta plus 54.74. Don't forget, you have a square. You have a square there which is still attached to the question. So all of this square. I don't have space, so let me cut some. So now what are we doing with this? So let's do, so it's going to be 1 over 2, 3 cos squared, and every inner part here, which I'm not bothered. This is only going to affect my x-axis. So movement of the graph towards the left and right. Okay, on the x-axis, where will the graph be positioned? So don't care. I want the least value. Least value means what? Smallest. Since this is cos squared, you know the only possibility is 0 and 1. And we know that we cannot take 0 because I can't divide anything by 0. So left with the option of 1. So half over 3 times by 1. So the minimum value that we are looking for is 1 over 6.